be on an SN1 reaction of a secondary alcohol. Since an alcohol is a bad leaving group, typically the reagent is an acid. We'll use aqueous HCl. There will be a rearrangement in this reaction, and the product will be a tertiary alkyl chloride. All right, starting with the alcohol, because the alcohol is a bad leaving group, we have to protonate it to make a good leaving group. The reagent is aqueous HCl, so the acid in solution is hydronium ion, because HCl will protonate water. The first step is proton transfer. And again, this creates a good leaving group. Now when this group leaves, it will form water, which is much more stable than hydroxide. So we can show water leaving in the next step, and we label that step loss of a leaving group. That forms a secondary carbocation. It's not super stable, but it's stable enough to form, and also water left. So we'll draw in water in that step as well. Whenever you form a secondary carbocation, you should consider rearrangement, because if you can do a hydride or a methide shift to form a more stable carbocation in one step, that is likely to occur. So if I draw in the hydrogen that's attached at that tertiary carbon, then I might recognize that this can shift over. We'll call this step rearrangement, or more specifically, hydride shift. That formed a more stable tertiary carbocation, and now we're left with nucleophilic attack, which is the last step. So the nucleophile in solution is chloride. We can show it attacking the electrophilic carbocation. We'll label this step nucleophilic attack, and that forms the product, which is our tertiary alkyl halide.